Hello, this is Tad Keeley with Renesas Electronics in Long Beach at the 2013 APEC show, and I want to spend a couple minutes to show you what's been one of a number of very exciting products that Renesas has shown, and it's been the one that's drawn the most people into our booth, in fact, and it's just over here on this board. It's what we call the miniPOL device, and this board actually has two separate power converters. So right about on the below the pin and above the pin are two separate converters. The bottom one is this very tiny device right here. It's 2.5 millimeters by 2.5 millimeters, and it's a 12 volt to down to 0.7 volt converter. So it's 0.7 to 4.5 on the output. And it's a 5 amp device. We have one that's slightly bigger here. It's 2.5 by 3.5. That's a 10 amp device. And in fact, the family's also got a third device. It'll go up to 15 amps in a 2.5 by 4.5. It's a chip scale package, a BGA package. So it's a very high power density miniPOL. It can meet the connected standby specs. So when it's in standby, it's a 2 milliwatt power loss. Some other really interesting features are we have a built-in current mirror so that we can use a super efficient inductor, because we don't rely on the inductor to provide a DCR input. So we get a little bit more efficiency on the inductor side. Also, it can switch into skip mode for very light load. So when even at about 100 milliamps load, any of these devices will maintain an efficiency over 80%. And if you go up to full load, say on the 15 amp device at 15 amps, it's going to be at about 88% at a 400K switching frequency, and around 92% at its peak efficiency, which is at about 6 or 7 amps, again with a 400K switching frequency. One final note is the switching frequency is programmable by an external resistor, so they can operate from about 100K to 1.5 megahertz. So we've got depending on how compact you want your design, we've got a great set of options and a full set of application tools online, a complete layout in terms of optimizing the capacitor and the inductors that surround the miniPOLs. So thank you for your time.